Hi, I'm Amir bin Norazmi, and I'll be talking about type of reaction use and products, and also the selection of catalysts for this reaction engineering 2 project. So, the type reaction is a trans-esterification reaction. This reaction involves two different kind of reactants, which is an ester and also a alcohol. The ester in this case is the olive oil, the oleic acid, and the alcohol is the methanol. When you react these two together, it will create methyl oleate and glycerol. So, for the selection of and comparison of catalysts, we have shown three different alkaline earth metal oxides, which is magnesium oxide, calcium oxide, and sodium oxide. So as you can see, sodium oxide has higher yield compared to other two metals. This is because these other two metals requires either more reaction time or also higher reaction temperature. Then we added a supporting catalyst inside the sodium oxide and we compare these results. So as you can see, there's two types of supporting catalyst, which is sodium oxide with silicon oxide and sodium oxide with calcium oxide. As you can see, the best yield is 95%. So the lowest time is at 10 minutes with 65 degrees Celsius. But as there's something notable here. After 1 hour, both catalysts will give lower yield. This is because after quite some time, the reaction will reverse and it will turn back into the reactants earlier. So, since this has a low reaction time, we believe that sodium oxide supported by silicon oxide is the best catalyst for this process with 95% yield at 10 minutes. So that's all for my part. Thank you.
Assalamualaikum and hi, my name is Aina Shahirah binti Yaakop and I'll be explaining the part 1, question 3, general procedure for the preparation of the catalyst. So the first step is strontium nitrate and calcium acetate with the same molar compositions are dissolved in the water and gel with ethanol under vigorous stirring. So for the next step, the gel is then kept in a beaker after the solvents are evaporated completely at 65 degrees Celsius. For the next step, solid powder is then calcinated at 900 degrees Celsius for 5 hours at the heating rate of 5 degrees Celsius per minute. The fourth step is strontium silicon catalysts are prepared at a molar ratio of 6 by dissolving strontium nitrate into deionized water. So for the fifth steps, the tetraethyl orthosilicate TEOS was then added into the mixture under vigorous stirring. And the next step, ammonium hydroxide is added into the mixture that leads to the formation of solid precursor. For the last steps, the solid precursor is then dried and calcined at 65 degrees Celsius and 900 degrees Celsius for 5 hours respectively.
Assalamualaikum, hi everyone. My name is Farhan bin Nizam, and today I will be talking about the characterization method of catalyst in the biodiesel production. Alright, so a characterization is defined as a general procedure to probe or measure a certain material structure. Therefore, we can divide the characterization method into three parts, which is the physical characterization, chemical characterization, and also morphological characterization. Alright, so the most suitable physical characterization method is the BET method. Why is that so? Because the BET method aims to study the physical adsorption of gas on a solid surface, therefore serve as a basis as an important analysis to determine the measurement of the specific surface area of a catalyst. Therefore, the surface area of a catalyst can be determined. So the next one is a chemical characterization. The most suitable chemical characterization is the EDX method, or the energy dispersion X-ray. So the energy dispersion X-ray is actually revolving on the concept of each of the component have a specific atomic structure which itself emits a peak at a specific electromagnetic emission spectrum. Therefore, the EDX method can determine how many percentage are available of the component are available inside of the catalyst itself. Alright, so last but not least is the morphological characterization technique. For this part, we are using the SEM or the scanning electron microscopy. This uses the concept of using electron to find the topography and also the structure and composition of the catalyst itself. Therefore, the exact morphological shapes and structure can be determined using this analysis.
Assalamualaikum and hi everyone. My name is Aina Shahirah Basir, and today I'm going to talk about the most suitable catalytic reactor for biodiesel production. So, for biodiesel production of trans-esterification of vegetable oil with methanol, heterogeneous catalyst is used, as heterogeneous catalyst is a green process and have a good recyclability where it can be used as many times as possible. So, due to the existence of the catalyst in this reaction, pig bed reactor is the most suitable reactor for this process. Bed reactor consists of a vessel with one or several tubes of pig catalyst particle. So the basic operation of the peg bed reactor is that the reactant will enter the reactor on the top and then flow through it. Upon entering the reactant will flow to a peg bed of the catalyst. So by contacting with the catalyst pellet, the reactant will react to form a product which then exit at the bottom of the reactor. Bed reactor are an economical choice in a large-scale production. This is because it can operate continuously due to a long catalyst life, which can lead to saving in annual cost and shutdown cost. In the process, the higher the conversion rate, the higher the ability of the reactant to form a product. So pig bed reactor can form a high product because it has the higher number of conversion per unit mass of catalyst compared to the other catalytic reactor. In the peg bed reactor, reaction mixture or the catalyst separation is easy because only heterogeneous catalyst is used in this type of reactor. So low amount of energy is needed for the separation process as the catalyst only remain in the reactor. Pig bed reactor also effective in a higher temperature and pressure. Furthermore, it performed better in terms of pressure drop and had a lower radial temperature gradient, indicating that this reactor had a higher effective heat conductivity. So it is shown that the most suitable catalytic reactor for biodiesel production is pig bed reactor.
Hello, my name is Zaidah, and I will discuss briefly on the current trends and challenges of biodiesel production in Malaysia. Since the early 1980s, Malaysian government had realized the importance of developing biodiesel in the long term, which then led to Malaysia emerging as one of the pioneers in the palm biodiesel industry. This was achieved through the aggressive stance by Malaysian Palm Oil Board (MPOB). Hence, development of biodiesel in Malaysia had been growing, and MPOB had partnered with a local plantation company to build the first biodiesel refinery in Labu Negeri Sembilan during the late 2005. According to Malaysian Biodiesel Association, there are 10 active biodiesel plants in the country with a total annual biodiesel installed capacity of 1.2 million tons. Here is the list of active biodiesel plants in Malaysia 2008. Okay, moving on. This list shows the global biodiesel production from edible oil feedstock, which appears to be increasing by year. As you can see, from 2009, all of these oilseed crops, which is palm oil, soybean, sunflower, and rapeseed, increases significantly from 2009 until 2014. Moving on to the next figure. This figure shows an overview of the current production capacity of biodiesel plants in Malaysia. The data shows that there has been a significant increase in the overall output of the Malaysian biodiesel industry from 2009 to 2014. Despite the large number of biodiesel plants in the country, the production of biodiesel still stands at 2.12 million tons, which is lower than the government's projected 10 million. It is also reported that Malaysian biodiesel production declined significantly from 2009 till 2012, which adversely affected exports. However, production and export of biodiesel picked up again in 2012 onwards due to increased investments and global demand for biodiesel. Okay, let's move on to the challenges of biodiesel production in Malaysia. The first challenge is due to the excessive land usage when planting palm trees. In Malaysia alone, up to 5,000 million hectares of land was used just for planting palm trees in 2011, and it is still increasing up to this day, according to the Malaysian Palm Oil Board (MPOB). Due to government policies on deforestation, there has been international backlash on the palm oil plantation program in Malaysia due to potentially harming the wildlife in these forests. This also leads to deforestation. Next is the price of biodiesel itself. According to Johari et al. 2015, the biodiesel prices are directly affected by the changes in crude oil prices. Currently, the crude oil prices have seen a big drop per barrel. This directly affects the price of biodiesel as well. The price of biodiesel is also affected by the cost of raw materials and the companies that sell them. These companies are getting bigger, and this causes these economies of scale, which means the cost per unit also gets bigger. This also causes potential customers to find alternatives to biodiesel until the prices of biodiesel are cheaper and stable. I think that's all for me. To close off this video, the future needs cleaner and more efficient fuel, and that is where biodiesel comes in. But research and development are important in the biodiesel production, as it directly affects the growth of this industry. Thank you.